Okay, so start with the ratio test. AM plus 1 is going to be minus. So the minus doesn't really matter anymore because we're inside the absolute value. Okay, so if you do m plus 1 here, you get 2m plus 2 minus 1 is plus 1 times by the reciprocal. So it's going to be, this goes to the top and this goes to the bottom. Okay, so these two have the same base. If you do n plus 1 minus n, we just get x minus 1. Okay, and we have these two. Let's just put them together. 2n minus 1 over 2n plus 1. And finally, 2n over 2n plus 1 is 1 over 2. As n approaches to infinity, this is just going to be 1, right? 2n minus 1 over 2n plus 1. Divide the top and bottom by n. You get 2 minus 1 over n, 2 plus 1 over n. That's going to approach 0. So we have 2 over 2, which is 1. So we really have a half of absolute value of x minus 1. And this has to be less than 1. So x minus 1 has to be in between 2 and negative 2. Add 1 to all three sides. Okay, so that's the interval of convergence, but we have to check the endpoints, negative 1 and 3. So if it's negative 1, we get negative 1 to the power of n, negative 2 to the power of n. So that together actually makes it, right, this makes it 2 to the power of n over 2n plus minus 1 and 2n. So that gets reduced. So we have 1 over 2n minus 1. So the series of this, by comparison test, we already know that this harmonic series is diverging, and this can be compared to it. So this is also going to diverge. So we cannot include negative 1. Let's check 3 now. The difference is when you plug in 3, it's going to be positive 2, right? So it's going to be minus 1, 2 to the power of n, 2n minus 1 is the same. So now it's a harmonic series, but it's alternating, right? Because of that, which means we just have to investigate. But we already got that this is something that we can compare to the harmonic series, the root function. And we know that's decreasing always, and it's approaching 0. So those are the two conditions you need for convergence by alternating series test. So that means this one we have to include, this one you omit.